I am very upset that our country is consistently just burning and burning and burning fossil fuels, yet there is an energy source that will almost never run out and will last America for at least 1,000 years, providing zero emission, completely safe, and reliable nuclear energy. Yes, it is nuclear fission, but it's completely 100% meltdown proof. And we can completely become a carbon neutral nation using this technology. That means we won't have to drill for oil anymore, frack for natural gas, or have any risk of a meltdown. So we won't have to worry about problems like Fukushima, 3 Mile Island, and Chernobyl. We will be completely self-reliable, self-producing energy nation. As this video from YouTube will demonstrate, it was uploaded by Gordon McDowell. It's titled Thorium and Energy Solution, Thorium Remix 2011. I will only show you the first 5 minutes of this film, of this documentary, which will talk about the benefits of thorium. There's very little risk involved. I've done a lot of research, and I have to say, thorium is very safe and reliable. And for those who do not think thorium will work because it's nuclear energy, well, you will see what he has to say.
The heavy water reactor will use about 0.7% of the uranium's energy value, and the light water reactor will use about half of 1%. They both do terrible. At normal pressures, water will boil at 100 degrees Celsius. This isn't nearly hot enough to generate electricity effectively. So water-cooled reactors have to run at over 70 atmospheres of pressure. You have to build a water-cooled reactor as a pressure vessel. The number one accident people worry about, pressure is lost. Water that's being held 300 Celsius flashes to steam. Its volume increases roughly by a factor of 1,000. If you don't get emergency coolant to the fuel in the reactor, it can overheat and melt. This is what drives the design of this building. So if this happens, all the steam is captured in this building. Now, the reactors we have today use uranium oxide as a fuel. It's a ceramic material, chemically stable, but not very good at transferring heat. If you lose pressure, you lose your water, and soon your fuel will melt down and release the radioactive fission products within it. So they have a series of emergency systems designed to always keep the core covered with water. We saw the failure of this at Fukushima Daiichi. They had multiple backup diesel generators, and each one probably had a very high probability of turning on. The tsunami came and knocked them all out. And people sometimes say, is nuclear energy safe? And the first thing I say is, well, which one? Thousands of different ways to do nuclear energy. Is the car safe? Well, which one? I had the good fortune to learn about a different form of nuclear power, the liquid fluoride thorium reactor. We can fully burn up the thorium in this reactor versus only burning up part of the uranium in a typical light water reactor. It's not based on water cooling, and it doesn't use solid fuel. It's based on fluoride salts as a nuclear fuel. You have to heat them up to about 400 degrees Celsius to get them to melt, but that's actually perfect for trying to generate power in a nuclear reactor. Here's the real magic. They don't have to operate at high pressure. They don't have to use water for coolant, and there's nothing in the reactor that's going to make a big change in density. Unlike the solid fuels that can melt down if you stop cooling them, these liquid fluoride fuels are already melted. In normal operation, you have a little piece of frozen salt that you've kept frozen by blowing cool gas over the outside of the pipe. If there's an emergency and you lose all the power to your nuclear power plant, the little blower stops blowing, the frozen plug of salt melts, and the liquid fluoride fuel inside the reactor drains out of the vessel, through the line, and into another tank called a drain tank. In water-cooled reactors, you generally have to provide power to the plant to keep the water circulating and to prevent a meltdown. But if you lose power to the lifter, it shuts itself down all by itself without human intervention. A staggeringly impressive level of safety, even if there's physical damage to the reactor. Thorium is a naturally occurring nuclear fuel that is 4 times more common in the Earth's crust than uranium. It's so energy dense that you can hold a lifetime supply of thorium energy in the palm of your hand. We could use thorium about 200 times more efficiently than we're using uranium now. Because the lifter is capable of almost completely releasing the energy in thorium, this reduces the waste generated over uranium by factors of hundreds and by factors of millions over fossil fuels. We're still going to need liquid fuels for vehicles and machinery, but we could generate these liquid fuels from the carbon dioxide in the atmosphere and from water, much like nature does. We could generate hydrogen by splitting water and combining it with carbon harvested from CO2 in the atmosphere, making fuels like methanol, ammonia, and dimethyl ether, which could be a direct replacement for diesel fuels. Imagine carbon neutral gasoline and diesel, sustainable and self-produced. You can see that uranium-235 is like on par with silver and platinum. Can you imagine burning platinum for energy? And that's what we're doing with our nuclear energy sources today. We're burning this extremely rare stuff. And we're not burning thorium. You know, some people who are kind of environmentalists, and they say, listen, nuclear power is not sustainable. We're going to run out of uranium. Okay, I will yield that point to you if we're talking about today's nuclear technology. In 2007, we used 5 billion tons of coal, 31 billion barrels of oil, and 5 trillion cubic meters of natural gas, along with 65,000 tons of uranium to produce the world's energy. So I have a friend who's trying to start a rare earth mine in Missouri. Jim, how much thorium do you think you'll be pulling up a year? He goes, I think about 5,000 tons. 5,000 tons of thorium would supply the planet with all of its energy for a year. And he goes, and there's like a zillion other places on Earth that are just like my mine. It's a nice mine, but it's not unique. It's not like this is the one place on Earth where this is found. Every time mankind has been able to access a new source of energy, it has led to profound societal implications. Human beings have had slaves for thousands and thousands of years. And when we learned how to make carbon our slave instead of other human beings, we started to learn how to be able to be civilized people. Thorium has 1,000,000 times the energy density of a carbon-hydrogen bond. What could that mean for human civilization? Because we're not going to run out of this stuff. We will never run out. It is simply too common.
Okay, I have a petition on change.org. So far, I only have 16 signatures. Well, unfortunately, that's not enough. And if you want to read what my petition is about, I am petitioning Dr. Ernest Moniz, who is the Department of Energy Secretary. And here is what my petition says. A lot of what I've written here is from what I learned from the rest of that documentary. The documentary is actually 2 hours long. And that 5 minutes was just the introduction. And I can't believe we are burning so much energy. I mean, states like Montana are burning nothing but coal. There is this on TeslaMotors.com. It will show you how much energy is being produced per state. See, supercharger. It'll say how is energy generated. Well, for some reason I can't find it, but thing is, we are burning so much fossil fuels right now. I'm going to go to co2now.org and look at where we are right now. 797.23 parts per million. And you see the rising? It will even show you at the rate it's been rising over the last 3 years. See? 389.92, then 391.65. So that's about almost point by 2. And then suddenly by 2012, it's jumped even more than. You see, if you add 389.92 plus minus 391.65 minus 389.92, you're going to get 1 point or 1 point like 70 something. But then between here and here, it rose 2.19. So it rose more between 2011 and 2012 than it rose between 2011 and 2010 and 2011. And this is July. Sorry, this is a. See? 392.92, then 394.30. So that's almost like maybe 1.38. But see here, it almost rose by 3 points. You see, our CO2 emissions is just going through the roof. And we are really changing our climate. And yet we have a chance to make the whole world carbon neutral. And I'm going to show you how much thorium we have in the whole world. We have enough to completely end global warming, yet our government's too lazy to do anything about it. Global thorium deposits. Reserve estimates of thorium around the world. This is as of last year, so it might even be a little more. Australia, 489,000. United States, 400,000. India, trust me, has much more. 319. Total world. Yeah, thorium-232. So when you fission thorium-232, it's going to decay to thorium-233 and then become uranium-233 once you hit it with a proton. The United States has enough thorium to power our country for at least 5 to 100 years to 1,000 years. Australia has enough thorium to power the whole world for several hundred years. And yet, what are we doing? We are just wasting fossil fuels. We have maybe 100 years left of the fuel. Already oil prices are going through the roof. Thorium can produce energy cheaper than coal. There's a book titled Thorium, Cheaper Than Coal. Or you can say now cheaper than natural gas. See, I'm just going to write C8, thorium, cheaper than coal. See? Right here. There's a book titled Thorium, Cheaper Than Coal. Yes, we can do it. We can end global warming. We could end the wars over oil. And yet we have wind, we have solar, we have hydro. We could utilize that along with thorium. But if we just use thorium as our only energy source without incorporating the other zero-emission energy sources, we will still have at least 900 years of thorium. But if we utilize hydro, geothermal, wind, solar, along with thorium, we could achieve a zero-emission economy. And that's without nuclear fusion for several thousand years. Cheap production of energy. And what are we doing now? We are burning our planet up. We are killing our planet. We're leading to climate change. We're leading to hurricanes. We're leading to more droughts. And yes, in rare occasions, we're leading to cooling weather. We're changing the chemistry of the earth. We're leading to ocean acidification because of all the carbon dioxide. And look what it says here. The oceans are acidifying at the fastest rate in 300 million years. How worried should we be? I mean, look at this. This is unbelievable. Even if that's not acidifying at that rate, they're still as acidifying, and they're going to destroy our coral reefs eventually. Why? It's not because of the rise in temperature. It's because the oceans are absorbing so much carbon that the oceans are becoming acidified, and we need to end this carbon immediately before it becomes too late.